Hi friends, today I'm going to discuss about the reduction of aldehydes and ketones. So reduction is one of the chemical properties of aldehydes and ketones. So there are two important reductions of aldehydes and ketones. So this chemical property can be coming like a name reaction because here we are going to study about two name reactions, or it can be asked like conversions or complete the reactions. Even like paragraph questions like A, B, C, D form also it can be asked. So reduction. So for reduction, we use some special reducing agents and all. In the first method, reduction of aldehydes and ketones to hydrocarbons. Hydrocarbons are the organic compounds which contain only carbon and hydrogen, no functional group. So we can reduce aldehydes are the compounds with CHO functional group and ketones are the compounds with the CO functional group. These two functional groups we can change it into hydrocarbons, the one without having any of the functional group. So there are two methods to do this. One is Clemmensen reduction, another one is Wolf Kishner reduction. So in both these methods, the outproduct is like that. Output is same only. Output in the sense the product is same only. Because in both these, you see the product, carbonyl group, see double bond O is present in both aldehyde and ketone. That changes to CH2. CH2 is a methylene group. Similarly, in the second reaction also I have written CO which changes to, finally it is changing into CH2 but there is an intermediate. The first one is called a Clemmensen reduction. So we use a reducing agent such as zinc amalgam and HCl. For example, if we write CH3CHO, ethanol. Ethanol undergoes reduction in presence of zinc amalgam and HCl. The process is this carbon and this oxygen. That will change to CH2. After that, CH2 and this H changes to CH3. So the second carbon becomes CH3. The first carbon is already CH3. It means we get ethanol changes to ethane. Once more I'll write CH3C double bond OH. This is ethanol. So this part is changing into CH2 and this H combines to form CH3 and that is this product. Similarly, if it is ketone like propanone, CH3, CO, CH3. When you add zinc amalgam and HCl, this CO will change to CH2. So CH3, CH2, CH3. We get propane from propanone. So always the product is a hydrocarbon having no functional group. So when we use zinc amalgam and mercury, zinc amalgam and HCl, we use the name Clemmensen's reduction. But instead if we use hydrazine, NH2, NH2 and H2, like H2 is the elimination only. When you add NH2, NH2, the reaction is called a Wolf Kishner reduction. Wolf Kishner. And in the first step, there is a nucleophilic addition reaction like this oxygen. I'll show you which oxygen. Yeah, this oxygen. The oxygen present in the carbonyl group gets eliminated with this hydrogen like this. As a result, water molecule is eliminating so that the resulting product is C after double bond, then this NH2, this part joined over there. So C double bond and NH2 is the intermediate. After that you add KOH, ethylene glycol and strong heating. Then this part will be changing into H2. So CH2 is the product. So instead of writing intermediate, if you are writing like CH3, CO, CH3, the ketone, with NH2, NH2, which is hydrazine. And in the arrow mark itself, we can write KOH, ethylene glycol, altogether. And then heating. Then this CO will change to CH2. We don't need to write the intermediate always. We can write the final product in this way. That is Wolf Kishner reduction. It means both Clemmensen and Wolf Kishner, the output is same only the procedure is different. Propanone, propan 2 on to propane. This is what I have written just now. Butanol. Butanol is CH3, CH2, CH2, CHO, 4 carbon aldehyde. Either Clemmensen or Wolf Kishner we can add. So that zinc amalgam and HCl I'm adding. So the last part CHO, which is changing into CH3. CH3, CH2, CH2, CH3. It is changing into Cu and then this H change combines with that CH2 form CH3. It's butane. So this is the first reduction. One more example, like cyclohexane carbaldehyde. Cyclohexane is this. Carbaldehyde is CHO. So that will change into, when you add zinc amalgam and HCl, that will change into CH2 first and then this H becomes CH3. Methyl cyclohexane. Now the second reduction of aldehydes and ketones to alcohol. So in this, aldehyde is always giving primary alcohol and ketones are always giving secondary alcohol. Here the products are different but the reducing agent is same. In both the case we can use lithium aluminum hydride. Primary alcohol is RCH2OH and secondary alcohol is RCHOHR. We can see here RCOR changes to RCHOHR and RCHO changes to RCH2OH. So the difference between these two, in the previous case the product is same but the reducing agents are different. Here the reducing agent is same but the products are different for aldehydes and ketones. Propanol. Propanol is CH3, CH2, CHO. So first let me write the product also, CH3, CH2, CH2OH. Propanol. So when you get a question like this, you have to think like CHO is changing into CH2OH. Aldehyde is changing into primary alcohol. That is by reduction. Then over the arrow mark we can write lithium aluminum hydride. Similarly, propanone. Propanone means it's a ketone having CO in the second position. We know that ketone never comes in the terminal position. Propan 2-ol is CH3, CHOH, CH3. Okay, so here CO is a ketone and this is a secondary alcohol, so that the reducing agent is lithium aluminum hydride. So this reaction you have to keep it in your memory, like reduction of aldehydes and ketones to hydrocarbons and alcohols, and some oxidation reactions are there. In coming videos I'll be uploading that. Thank you.